Bienvenidos, Ushamadid, and welcome UMGC learners from CMIT-455, Section 6380, from the spring 2021 semester. This is the CCNP ENCOR version 8 curriculum from the Cisco Networking Academy, and in this activity, we're going to be turning our attention and focus now to IP services, and specifically, we're going to be looking at configuring NAT for IPv4 in Packet Tracer Activity 15.2.2. Now, NAT for IPv4 can be a stumbling block for many learners because it starts to introduce not only some new concepts, but some new terms. So let's take a look at the activity as it stands right now. So here is activity 15.2.2, and you can see it's going to be a very straightforward activity where we have a static NAT configuration here on local PKA, and then we have PC1 on LAN 1, and PC2 on LAN 3. And so while we'll be doing a static NAT configuration, which is a 1-to-1 configuration, in other words, we're going to be assigning a single inside local address, and that is what the 192.168.20.254 represents. That is the inside local address. And if you think about it like this, your inside local addresses are typically your RFC 1918 addresses. And so if we were to take a quick look as a review in terms of the RFC 1918 addresses, and we're going to come back to that document in just a second, 1918 addresses, you'll see that these are the addresses that can be allocated for private internets. In other words, these are the addresses most commonly found. Now, do you have to use RFC 1918 addresses? You don't, but it's commonly found that that is what is being done. And so if I was to scoot down right here to the private address range, and you should all be familiar with these ranges of addresses. Now, there's another important fact behind the private address space being used, and that is that service providers will filter out these address ranges from being routed on the public internet or from being sent out onto the public internet. And that's really the definition of the private address space, is that it is not routable in its native form over the internet. Now, can we do a GRE tunnel to facilitate that? We absolutely can, but as it stands right now, you would not be able to route a 10 dot or a 172.16 or a 192.168 over the internet natively. Again, there's ways to do it, all kinds of ways to do it, which we'll get into later, but that is the RFC 1918 address space that we're referring to when I say that this is my inside local address. Again, think of it like this. The inside local address is the actual IPv4 address that is configured on that device, on this local PKA server. And PC1 is going to have an inside local address, and PC2 is going to have an inside local address. And then we have this reference here to an outside address. So this would be the inside global, right? So inside local, meaning my private RFC 1918, inside global being what this device is going to appear to be to everyone on the outside of the network. And so they call it the inside global. Again, it's how this device, in this case right here, with the 209.165.202.130, it's how that device, local.pka server, is going to be seen by everyone out here on the internet. Because it's not going to be seen by its inside local address, because as I just described, those are not publicly routable on the internet. And so that is really what NAT is all about. It's sort of about tricking the edge router, and the edge router really facilitating the change of the inside local address to an inside global address. And again, NAT all came about as the result of everyone realizing that the publicly routable IPs were quickly being depleted, and that depletion is complete at this point. So there are no more available blocks to assign to the internet registries, the regional internet registries, and so therefore they saw that that was going to happen, and so they had to come up with a fix. And NAT, network address translation, is that fix, because everyone can use the same private RFC 1918 addresses, as long as when we go outside of our network, we have a distinguishable, unique, publicly routable IP or IPs that can be used. So let's dive into this activity. And again, we'll roll back to the document I had up earlier because we're going to talk about the order of operations. So does router 2, which is the only device we're configuring in this activity, does router 2 route the packet first and then do the translation? Or does it do the translation first and then route the packet? And does it matter if it's coming into the router from the internal network or returning from the outside? And so we'll break all of that down. And again, I'm going to point you to an extremely valuable document to understand NAT and the order of operations that a router will undertake before and after it attempts or it performs network address translation. And I'm going to talk about the use cases because we're concerned about three types of NAT. Static NAT, which we're going to configure right up here, which is a one-to-one translation. And the use case for static NAT is when you desire and you want PCs on the outside, like outside PC here, to be able to access in some form or fashion. And what I mean by that is we could maybe just have a web server here. Maybe this is an anonymous FTP server here. And so realistically, you would probably have some kind of a firewall that would be controlling the ports. Now, not to say that you couldn't do it on the router, but in enterprise networks, typically you're not doing your packet inspection on the router, so to speak. You're using a firewall device, a perimeter device of some kind. So, but the use case for static NAT one-to-one is when I want outside devices to be able to access inside devices. Now, the next NAT use case is referred to as dynamic NAT. Now, sometimes you're going to hear this referred to as many-to-many. However, keep in mind, technically, we could have one inside host and then a pool of many, i.e., more than one, even though you could probably do it with one. You would have more than one publicly routable IP, right? Now, the trick with dynamic NAT is that you need to ensure that you have as many publicly routable IPs in your pool as you have inside local hosts that might be using that pool. Because dynamic NAT is done on a first come, first served basis. And once the IP has been claimed by an inside host, once one of the pool, publicly routable pool IPs has been claimed by an inside host, the default is 86,400 seconds, 24 hours that it will hold that, so think of it as a lease on that publicly routable IP in the pool. So the problem, as you can see, is if I have more inside hosts than I do publicly routable IPs in my dynamic NAT pool, then the first, let's say, 3 people are going to get those 3 IPs in the pool. Everybody else is out of luck. And then that's where the third use case for NAT comes in, port address translation. And we call it PAT, and you might hear it referred to as dynamic NAT with overloading or dynamic NAT overload. And the stress on that word overload is very important. Now, we'll be configuring port address translation for everybody else. And again, we'll do a static here, and you'll see that you can do a static and then still have port address translation, and the static is going to override that because we'll be doing port address translation for LAN 2, anybody else that would be on LAN 2 who may need to get access to the internet. So let's dive in here. The first thing we're going to do is we're going to jump onto router 2. Again, the only device we're configuring in this activity. And it's here that we're going to go through some of the steps. So we're going to use a named ACL to permit the addresses from LAN 1, LAN 2, and LAN 3 to be translated. Because remember, we have to tell router 2 who is a candidate for network address translation. Who are we looking to match when we see traffic coming into these inside interfaces? And I think it's serial 000 and 010 probably here, or 001, and then probably gig 00. And actually right over here we can see, yeah, so serial 000, 001, and fast Ethernet 000. And so when we create this ACL, this is going to be identifying who it is we want to allow router 2 to perform the network address translation function for. Now, we're going to go ahead and say IP access list, because it's going to be a named access list. And we are going to say that it's going to be, it doesn't say standard or extended, but it's typically with NAT. The majority of the cases, when you're configuring NAT on a router, you're going to be using a standard ACL to make that identification, because I don't need ports and source and destination. I just need the source. Where is the traffic coming from that I'm interested in natting? And so we'll say IP access list standard R2 NAT, and that's the name of our standard ACL. Now, we need to match the LANs and specifying, I'm looking for these little things that are in packet tracer activities here. So the LANs have to show up as the order as they're listed there, LAN 1, LAN 2, and LAN 3. So I would say for LAN 1, permit 192.168.10.0, and then put in my wildcard mask, the inverse mask of what the subnet mask would be. And the subnet mask for a /24 is 255.255.255.0, meaning the inverse of that is 000.255. And I think you'll see that we'll end up with some points here as we work our way through. So now if I do LAN 1, LAN 2 is 20, and LAN 3 is 30 in that third octet. So those are the three networks. You can see we've picked up 20%. And again, specify the LANs in this order, and we used R2 NAT as the name, and so we're done with that right there. If I say do show access list, let's take a look at our access list, and you can see there it is. Those are the three networks which we are going to allow to be natted on router 2. So anybody in those ranges, right? Okay, so create a NAT pool named R2 pool. The pool should use the first address from the 209.165. Now this can be tricky when what we're doing is we're using a single publicly routable IP, and you'll see in the configuration where it might be a little tricky. All right, so let's go ahead and say IP NAT pool, and then we're going to put the pool name, and we have to have R2POOL, and then you'll have your starting IP address. So remember, the activity is saying you should use the first address from that /30. Well, if 128 is the network ID, and it is in this case, the first usable address in that range would be the 129. And that's really what they're asking for. So I'm going to say 209.165.202.129. Now here's where the syntax I alluded to earlier might get a little confusing. It's now asking for the ending IP address. Now remember, the pool should use the first address, meaning the starting IP and the ending IP are the same IP. If I wanted to use two addresses, a second address, I would change this out to 130. But again, that's not what it's asking for here. It's asking for the first address of that range to be used. And so my starting IP address and my ending IP address are the same IP address. That is how you say that single address. Now, when you're doing port address translation, there's also an approach that can be used where you signify the interface, the outside interface that you would like to use. They're not doing that in this activity. And if you specified this serial interface here, which is serial 010, it would grab the IP off the interface. In other words, we'd be using 209.165.200.225. In this example, we have, maybe the service provider has allocated us a range of IP addresses that we can use, publicly routable IP addresses that are not part of the transit segment subnet. Because clearly you can see that 202.129 is not in this /27, which represents the transit segment here between our edge router, router 2, and the internet cloud. And so that is how you say that single IP. And you might not believe me just yet, but wait, because we'll see the percentage will go up, but we're not done yet, because now I need to specify the net mask. And you actually say, so when it says net mask, you type net mask out. You don't actually put in 255, 255, 255, 252. So here's where I say net mask 255, 255, 255, 252. Again, when you see that, it's not telling you like here, right after the IP, you put the net mask. You have to put the net mask keyword, then the subnet mask in dotted decimal notation. And so I'll hit enter. And you'll see we got 15 percentage points for that. And so that is how we say use that single IP address as our port address translation address. And you'll see we're going to do the port address, the dynamic NAT with overload, PAT, port address translation, is about to happen right now. So configure NAT with the ACL and NAT pool you have created. So we're going to bind together the NAT pool and the ACL into a single statement so that it's clear that the addresses that we are permitting to participate in network address translation know what the pool of addresses is, and more importantly, how they will leverage those addresses, or address in this case. Because to do dynamic NAT right now would be crazy. Because I'm saying that I've got 254 IPs in here, and 254 IPs in here, and 254 IPs in here that could possibly be allowed to, that are theoretically going to want to use NAT. And if I only did dynamic NAT, what we're saying with this statement is, okay, we've got one, so it's literally first come, first serve for the first PC that wants to go outbound to the internet is going to get that address, and then that's it. Everybody else would be locked out with regular dynamic NAT, where we, quote unquote, have a pool of addresses. Our pool is one address. So let's go ahead and say IP NAT source, IP NAT inside, and then you can see we'll put source, right? So how are we going to do the source address translation? Am I going to be doing a static NAT configuration where I specify the inside local and inside global values? And static NAT, by far the easiest of the three types of NAT to configure that we've discussed. But here I'm going to be using a list, an access list. And you can see, you say IP NAT inside source list, and do we have a number? No, we have a name for that list. It's R2 NAT. So IP NAT inside source list, And do we have a pool? Or here's where I could place the interface. But we don't use the interface here. We're going to say pool, and then the name of the pool, R2 pool. And here's where most learners will forget that this is the difference. This is what has to be done to differentiate between dynamic NAT and dynamic NAT with overload. And there's the overload keyword. If I was to hit enter right now, I would be creating a dynamic NAT scenario where I have a single publicly routable IP in my pool and up to 700 plus, theoretically 700 plus inside local clients who might be fighting to get that one IP, which is why here we say overload, because now I'm doing dynamic NAT with overload. I'm overloading it. And if you think about it, it makes sense. I'm overloading that single publicly routable IP by saying we're going to use source and destination ports in addition to source and destination IPs to differentiate all of the internal clients from one another. So now we're not fighting over a single address, we're fighting over 60 plus thousand ports that are available to differentiate all of the connections. And then the IPs are involved as well, right? Because you're going to have your inside local IP address and a port number that's going to be associated with that. And we'll see that when we talk about show IP NAT translations and show IP NAT statistics. So this is the difference. That overload keyword, and I hit enter, means we are now doing dynamic NAT with overload, PAT, port address translation. Significant difference between that and regular dynamic NAT without overload. And so now we're going to configure a static NAT statement, and we're going to do it for the local PKA. And as you're going to see, static NAT is very low-hanging fruit. IP NAT inside source, it's not a list that we're referring to as to who is going to be using the pool of addresses. We are doing a one-to-one translation here. We are saying that this inside local IP of the server 192.168.20.254 is going to be statically translated to this inside global publicly routable on the internet 202.130. And so outside of the internal network, this publicly routable IP is how the local PKA server will be identified or seen, if you will, out here on the public internet. Now, let's test something before I put that, and actually we could put the statement in right now and be done with it, and you can see we're at 65%, and we've got a few tasks to complete still, and you'll see why I'm going to do this right out of the gate. So if I come here and I say 209.165.202.130, this is the publicly routable inside global address for local PKA server. And I hit enter, and you can see we've got nothing going on here. I can't see the web page that I would anticipate I would be able to see. In fact, if we were to pull the local PKA up, and we should see HTTP is on and HTTPS is on. So this should be working. But again, as I had alluded to, there are some NAT statements that are still missing, because now what we need to do is we need to tell router 2 which interfaces represent the inside local networks. In other words, the interfaces on which I'm going to be monitoring and watching to see, do I have any addresses in the ranges that have been identified, configured in my standard named ACL R2 NAT that are eligible and need to be translated so that they can get out to the public internet. And the way that that works, and this is probably the easiest part of the activity, but it's also the part of the activity that many learners overlook, especially when they don't have a reminder saying, hey, don't forget to configure the interfaces that will participate in the NAT process. And so, we're going to say IP NAT inside serial 000 is the 10.111/30, and that's the transit network. I'm sorry, the 10.112/30, but it's that serial interface right here. And so we're telling this interface any traffic that shows up here that matches that range of those 3/24s, and again, it's only going to match this one here, go ahead and allow that to NAT if that's where the traffic is routing. The same is true of LAN 3. We have a static here, but we've also set it up so that if someone out on this subnet, LAN 2, this guy right here maybe, right, make-believe PC over here, this guy doesn't have a static NAT translation. So he would participate in the dynamic NAT with overload, the PAT pool. That's how he would get access out to the internet. So let's finish this up here. So we would say IP NAT inside for serial 000. We would then go to serial 001. Hit the up arrow a couple times. Say IP NAT inside. We would then also go to fast Ethernet 000. Wait a minute, I got that right? Okay, it says fast Ethernet 000, but we get an error there. So let's say do show IP interface brief. Maybe a typo in the activity. And yes, just a typo in the activity there. The interface is actually fast Ethernet 00. So interface fast Ethernet 00. And we're going to say IP NAT inside on that interface. You can see we're at 92%. So my guess is the final statement is we need to identify the outside interface. The interface on which traffic returning to the router, returning to our enterprise network, is going to be sorted out because we have to do some translation and then some routing. And it's the opposite on the way from these local area networks out to the internet where we're doing the routing and then the translation. And I'm going to show you that in just a second, but let's finish this here and let's get into interface serial 010 and say IP NAT outside. And it's that simple. And you can see we're now at 100%. So now let me come to the outside PC. And there, take a look. Now it says, welcome to local PKA. Because now we have a translation. If I say do show IP NAT statistics, NAT translations, you can see that we have traffic going to port 80 and using this inside local address, but here's the inside global address that shows up for, and they give you nice columns here, right? Inside global, inside local. Now, the outside local and the outside global, 99.9% of the time, those are going to be the same IP. In cases where it's not, it's when you have something similar to a back-to-back NAT, where you're natting twice in the outside, right, or on the outside. So typically here you will see the exact same IP, and there's a random high port number, right? And it's gobbled in there, but you can see, it's gobbled in here, but you can see 1031 before it starts this next IP. There's that random high port, and that is how the static NAT is working, right? And you can see there's our static NAT entry for the web server local PKA. Now let's test some of these PCs. Can the PCs get out to Cisco PKA, which is 209.165.201.30.30? Okay. And I can hit Cisco PKA. What about PC1? Can I ping the outside PC, 209.165.201.201.14, and we've got connectivity. And again, if I was to come back here and say, do show IP NAT translations, get some space there, you can see there's my static mapping. Here's the HTTP sessions, right? And here are those ICMP ping packets with not a random high port number, but with a sequence value that we have here at the end. And so that is, in its essence, network address translation. If I clear the screen here and we come to this document, I highly recommend a read of this document for the Nat Order of Operations, and specifically right down here. And we are interested in when traffic is going from the inside to the outside, the routing will take place first. Then the natting of the traffic, the local to global translation, gets done second. So when PC1. So when PC1's traffic hits router 2, it gets routed first. The destination, where is it going to? And that's when the router learns, oh, it's going to go out my serial interface to the internet. And oh, by the way, I'm natting that traffic. And that's when it translates it to the 209, whatever we've got, 209, 165, whatever. Think about that. It makes sense. Because what you don't want is traffic to show up on this interface here and to have it translated first and then routed. What if it's going to this network? Do I need to translate it to a 209 to come to the local PKA? No. This is inside my network, right? And this is the outside of the network here. So I don't want it translated first. I want it routed first. I want the router to say, yeah, it's going to go out this interface, which is my publicly routable interface. And I've got an IPNAT outside statement. Therefore, I'm going to translate the IPv4 inside local address to an inside global address. And it's just the reverse on the way back in. Take a look at the process here. We NAT the traffic first. When the traffic returns, we do the global to local translation first, and then we route that traffic back. And you can see here, policy routing, or PBR, is actually done before the normal routing. And again, that also makes sense. You can see it happens over here as well. And that makes sense. We haven't covered PBR yet, but that also will make sense when we do talk about PBR. But you can see the traffic returning to the network will be natted first, will be translated first, and then routed. And if you think about it, that makes even more sense, because over here on the inside, these guys over here, they have no idea what the 209s and the ports and the IPs translate to, but router 2 does. So router 2 changes it from a 209.165 to the inside local RFC 1918, 192, 168, and then router 2 knows, oh yeah, well, router 3 is advertising a route to get to the 192, 168.30, so I know to come this way to go there. Or router 1, if we're doing OSPF or EIGRP or whatever the IGP is, router 2 would know, even a static would know that after that NAT translations takes place, that if, oh, I see on the inside of that packet after translated, it's going to go to the 192.168.10. That's where the traffic would go. All right. Well, that is a very good look at NAT for IPv4. And let's get that out of the way here. And that is going to do it for this packet tracer activity on configuring NAT for IPv4. Thank you so much for watching. Hopefully this has clarified network address translation for you, and I hope to see you in the next video.